The world of business is constantly changing and developing. To have a healthy living business, it is essential to grow and evolve. But sometimes that growing can be too organic and too chaotic. Kyocera is actually an evolutionary business, helping companies to become fitter and smarter. Whatever the world of business creates, let us sort it out.
Welcome to the Lean Six Sigma Introduction e-learning course, providing you a high-level overview of the fundamental concepts of Lean Six Sigma. In this course, we will cover the following topics. What is Lean? What is Six Sigma? What is Lean Six Sigma? What is the DMAIC Cycle? Who are the key players within Lean Six Sigma, and when to apply Lean Six Sigma? So, let's begin. What is Lean? Lean is the elimination of all forms of non-value added work, from the customer's perspective, in business transactions and processes. The history of Lean has its origin in the 90s of the 19th century. Frederick Taylor was an American mechanical engineer. He is regarded as the father of scientific management, and was one of the first management consultants. Taylor began to look at individual workers and work methods, to figure out the one best way to do every job. The result was time study and standardized work. Then, Henry Ford came into play. He was an American industrialist, and the founder of the Ford Motor Company. His introduction of the Model T automobile revolutionized transportation and American industry. He fashioned the first comprehensive manufacturing strategy. His Highland Park plant pioneered flow production, by placing fabrication equipment in process sequence. The result was a much faster production time, and a much higher production output. In the 60s of last century, a man named Taiichi Ohno developed what today is commonly known as lean management. Ohno was a Japanese businessman, and assembly manager for Toyota. He is considered to be the father of the Toyota production system, which became lean manufacturing in the United States. He recognized the central role of inventory, and developed practical methods to implement the concept of just-in-time, such as Kanban. He also identified the 7 wastes, which need to be eliminated, as the central focus of Lean, to increase profitability in business processes. In Lean terms, value is always defined by the customer, and there are 3 ways we can categorize value. Waste, or META, is typically referred to as a non-value-add activity. Essential activities are called value-add activities, for which the customer is willing to pay for. Finally, there are some activities that fall somewhere in the middle, and we call these business non-value-add activities. These tasks must be completed, even if they are not traditionally defined as value-add. An example of a business non-value-add activity would be tasks required to meet regulatory or legal requirements. These actions are not defined as adding value to a process from the customer's point of view, but they cannot be avoided or eliminated. This pie chart provides the answer to the question, which of the 3 value categories do you think is most commonly found in a typical business process? In a typical business process, whether manufacturing or transactional, a tremendous amount of the activities are non-value add. Most processes are 3% to 5% value add, and maybe 10% to 15% business non-value add. But the majority of processes are non-value add. To understand Lean, it's important to know, what is exactly waste, or non-value-add activities? As the central focus of Lean, is about the reduction of waste. Lean defines 7 types of waste. These are motion, transportation, waiting, overproduction, inventory, overprocessing, and rework. Let's take a closer look at each of the 7 types of waste. The waste of motion typically refers to the actual movement of a person. This might be unnecessary motion within a workstation, or motion in a job task that takes too much time to complete. Next one is transportation. Any conveyance of a product is considered waste. Assembly lines, shipping, and email all move products and services, but do not add value. Transportation does not transform a product or service, it just simply moves it. The waste of waiting implies waiting for parts or information. An absence of flow, or a delay in the process, is one illustration of waste and something we want to eliminate. The goal is to be able to respond to the customer's request, with no delays to services or goods. Waiting is one of the largest wastes that can be identified by Lean. The next type of waste is overproduction, and that is producing too much or too soon. It's producing to forecast rather than demand. Overproduction consumes our resources with things the customer does not need, and has not asked for. If we listen to customer requirements first, we can respond with goods and services that meet those demands. Inventory is any type of supplies and materials that are kept in a quantity above the minimum to get the job done. Inventory takes up space and ties up financial resources. Furthermore, too much inventory, in terms of work in progress, is a major contributor to long lead times. The waste of overprocessing is about any activity that adds cost but no value. Many times, we do operations that the customer does not care about, or does not ask for. In other words, overprocessing simply means doing things that are redundant. Finally, the last type of waste is called rework. Rework is any repair or change to a product, after it's been made, or any correction of something that was not done right the first time. One of the primary components of Lean is value, and something is only valuable if it was done right the first time. After clarifying the term value, and describing the types of waste, we now want to talk about value stream mapping. Value stream mapping is the most essential and powerful Lean management principle and tool. Value stream mapping is used to map and visualize a business process. A value stream contains all actions and process steps, which are required to create a product or service. In addition, a value stream map should include process data, to quantify and demonstrate the process performance in a graphical way. By creating a value stream map, a common understanding of the current state of the process is realized. Furthermore, and most important, it helps to identify waste and opportunities for improvement. This graphic now shows a value stream map created by using a process mapping software tool. Apart from the diagram itself, that represents a process, showing the steps as boxes of various kinds, and their order by connecting them with arrows. You can see that there are different types of data elements added to the process map. And data is what separates a value stream map from a standard process map or flowchart. Your goal should be to capture as much data, in terms of process performance metrics, as possible. Typical value stream metrics are process lead time, cycle times, waiting times, and rework or defect rates. Now that the process cycle is visualized, and relevant performance metrics are visible, we have a perfect basis to identify waste, in and between process steps, as this is the primary purpose of creating value stream maps. It makes it now much easier to clearly point out weak points along the process. And when we talk about weak points in the language of Lean, we talk about the 7 types of waste. Within the scope of a waste analysis, the process improvement team should investigate the value stream map and identify waste in the process. To indicate types of waste, or problem areas in a value stream map. Graphic symbols, such as an explosion symbol, or simply annotations, can be used and added to the map accordingly. This will mark areas for improvement to focus on, when developing ways and solutions, to reduce the non-value added time spent in a process. Before starting to create your value stream map, here are a few tips to keep in mind. First, use sticky notes, instead of using a software tool to document your process. It's easier to make changes, and, most important, it contributes to employee engagement and involvement. Next, use as much space as you can. Don't restrict your mapping activity to a single sheet of paper. Find a large piece of butcher paper, or a whiteboard, to document your map. The more space you have, the more detailed you will be. Finally, always create value stream maps with a team. Rarely, only one person has all of the process knowledge. To make sure that the right amount of knowledge is given, you should answer the question of who is involved in the process when building the team. In order to improve a business process, through the elimination of waste, Lean includes a set of principles and tools. As this course is about providing you with the very basics of Lean, the different tools will not be introduced and explained, one after another. What you should know at this stage is that Lean thinking is fundamentally just good common sense. It's about lining up value creating actions in the best sequence, and conducting these activities, without interruption, whenever someone requests them, and performing them more and more effectively. In plain terms, this means that when you realize a process that flows without interruption, and includes only those actions, or process steps that add value from the customer point of view, you will achieve a Lean process. What is Six Sigma? Six Sigma is a statistical-based methodology used to reduce variation and eliminate defects in business transactions and processes. The history of Six Sigma has its origin in the 20s of last century. Walter Shewhart was an American physicist, engineer, and statistician, sometimes known as the father of statistical quality control. Shewhart introduced the control chart, and the distinction of special versus common cause variation, as contributors to process problems. In the mid-80s of the 20th century, Six Sigma was introduced by Bill Smith at Motorola. Smith was an American engineer, and is known as the father of Six Sigma. As a management concept, Six Sigma seeks to improve the quality of process outputs, by identifying and removing the causes of defects, or errors, and minimizing variation in business processes. Then, in 1995, Six Sigma became well known, after Jack Welch made it a central focus of his business strategy at General Electric. Welch was chairman and chief executive officer of General Electric. He said, Six Sigma is the most important initiative General Electric has ever undertaken, as Six Sigma is about reducing variation and eliminating defects. We need to clarify these terms. First, we will answer the question of what is variation. Variation is the range of difference between the statistical mean and all data points that are used to calculate the mean. In other words, it is the extent to which process performance varies around the average. In Six Sigma, variation is measured by calculating the standard deviation. For a better understanding, we will use an example in the following, to demonstrate what variation means. In this example, customers are calling the customer support of an online retailer, due to different kinds of service requests. The time it takes, until someone from the call center picks up the call, is called hold time. The hold time represents the waiting time in this process. Currently, the company receives a lot of complaints from customers. One thing customers complain about is the inconsistent hold time. Sometimes it takes 2 seconds until somebody picks up the call, other times it takes several minutes, they say. The service manager of the company was surprised when he heard about this issue. He always thought that the quality of the hold time is absolutely fine. In order to verify the quality of the hold time, the service manager collected some sample data the call center system has recorded. The table shows the data collection, consisting of 50 samples, representing the hold times in seconds. Next, the service manager analyzed the data collected. First, he calculated the mean, or average. In statistics, the mean is a measure of central tendency, that is determined by adding all values, divided by the total number of values or observations. In this example case, it means that in average, a customer needs to wait 30 seconds, until someone from the call center picks up the call. As the manager recognized this result, he felt good about it. He said that an average waiting time of 30 seconds should be okay for the customer. Then, a colleague reminds him of what the customers actually were complaining about. He recommended the service manager to calculate the variation of the hold time, in order to understand the real problem. The service manager followed his advice, and measured the variation by using the formula for calculating the standard deviation. In statistics, the standard deviation is a measure of dispersion, that is determined by taking the square root of the sum of the squared differences of each value from the mean, divided by the total number of values or observations. In this example case, it means that each individual value of the sample data varies or deviates 60 seconds on average from the mean, that is 30 seconds. This variation, or uncertainty regarding the hold, or waiting time, negatively impacting customer satisfaction, as the customer does not feel the average, he feels the variation. And this variation, for example, results from really bad experiences, like the 200 or 300 seconds of waiting time. What the customer expects is a consistent performance he can rely on. After dealing with this issue, the service manager now understands the problem, and is willing to reduce the variation, to increase customer satisfaction. Now, that we have answered the question of what is variation, we need to clarify the term defect, within the scope of Six Sigma. A defect is a measurable product or service characteristic that does not meet a clearly defined customer requirement. Or in other words, any process performance outside of defined specifications. In Six Sigma, defects are measured by calculating defects per unit, or defects per million opportunities. Let's get back to our example case to better understand defects. Remember the initial situation. The online retailer has received a lot of complaints from customers. In addition to the inconsistency or variation of the hold time, some of the customers also say that they simply need to wait much too long until somebody picks up the call. In order to exactly know what too long means, from the customer perspective, the service manager arranged a survey addressed to a selection of customers. This survey only included the question of how long are you willing to wait when calling our customer service. The result was that an average customers are getting angry, and normally hang up after 1 minute of waiting on the phone. By conducting this survey, the company has collected the voice of the customer, and translated the customer issue and need into a measurable requirement, defined by the customer. Now, that the service manager knows the measurable requirement, also called specification limit, that is 1 minute, he again looks at the sample data he collected to see if the process meets the customer requirement. When going through the sample data, the service manager identified 6 values, or hold times, that exceeded the customer requirement of 1 minute or 60 seconds. As these values are not acceptable to the customer, we call them defects. In order to assess these non-compliant conditions, the service manager measured the average number of defects per unit, To do this, he counted the total number of observed units, and added the number of defects he identified. By simply taking the number of defects, divided by the number of observations, he calculated the defects per unit. Another way of measuring defects, or process capability, is to calculate defects per million opportunities, as this is a very commonly used measurement in the Six Sigma world. It is calculated by taking the defects per unit, multiplied by 1 million, divided by the number of defect opportunities per unit. This measurement indicates how many defects would arise if there were 1 million opportunities. In this example case, we have 120,000 defects per million opportunities, assuming that there is only one opportunity to create a defect, that is when the hold, or waiting time exceeds 60 seconds. After performing this comprehensive data analysis, the service manager has learned new aspects about his business, and now wants to drive and establish process improvement activities in his department in a structured way. As a consequence, he set up process-related targets for the upcoming new financial year, based on the reduction of variation, and the elimination of defects to increase customer satisfaction. Now we come to the point, where we want to clarify, and understand, why Six Sigma is actually called Six Sigma. To achieve this, we need to clarify the term Sigma level. As well as defects per million opportunities, the Sigma level is a measure of process capability. Broadly speaking, process capability tells you how good or poor a process is performing. The Sigma level is measured in standard deviations from the process average, or mean, to a target or a specification limit. Each Sigma level corresponds to a related defects per million opportunities value, as you can see in the table below. A 2 Sigma level process means that this process produces about 300,000 defects per million opportunities. As the Sigma level increases, the number of defects drops. Notice that it is not a linear function. 1 unit of increment of Sigma level corresponds with a dramatic decrease in defects per million opportunities. When reaching Six Sigma, we reach what this methodology is all about. It's the ultimate goal of achieving a Six Sigma level process, that is producing only 3.4 defects per million opportunities. This quality level is so high, that customers will virtually never see defects. In addition, process capability can be also described by the percentage of defect-free units. This value is the flip side of defects per million opportunities. Corresponding to a Six Sigma process, that is producing 3.4 defects per million opportunities, we could also say that this is a process in which 99.9997% of the units produced are statistically expected to be free of defects. In the following, you will begin to get a feeling for what Six Sigma quality means, and why 99% good is sometimes just not good enough. When looking at air travel, 99% good would mean 6 near-fatal plane crashes per day, at most major airports. This is equivalent to a 3.8 Sigma process. Increasing this quality to 6 Sigma would result into only 1 near-fatal plane crash per year. Within surgery, 99% good would mean 5,000 incorrect surgical operations per week. On the other hand, only 2 incorrect ones would occur, if the quality is 99.9997% good. With regards to the financial sector, a 3.8 Sigma process would mean 140,000 incorrect financial transactions per hour. In contrast, in a 6 Sigma process, only 75 transactions would be incorrect. In order to improve a business process through the elimination of waste, Lean includes a set of principles and tools. As this course is about providing you with the very basics of Lean, the different tools will not be introduced and explained, one after another. What you should know at this stage is that Lean thinking is fundamentally just good common sense. It's about lining up value-creating actions in the best sequence, and conducting these activities, without interruption, whenever someone requests them, and performing them more and more effectively. In plain terms, this means that when you realize a process that flows without interruption, and includes only those actions or process steps that add value from the customer point of view, you will achieve a lean process. What is Lean Six Sigma? Lean Six Sigma is a management concept used to effectively improve business processes, based on the combination of the different tools of Lean and Six Sigma. Organizations face rising costs and increasing competition every day. Those ones that implement Lean Six Sigma correctly achieve significant benefits that contribute to competitive advantage and to changing the culture in an organization, from reactive problem solving to proactive problem prevention. Specifically, the proven benefits are diverse. First, Lean Six Sigma achieves faster processes by removing all forms of non-value added work, according to the 7 types of waste. Secondly, Lean Six Sigma aims to realize higher quality, in terms of process stability and capability, through the reduction of variation, and the elimination of defects. Since the methodology involves a strong focus on customer needs and requirements, another significant benefit of using the tools and concepts of Lean Six Sigma is an increase in customer satisfaction. The primary desired benefit of all process improvement activities, within the scope of Lean Six Sigma, is a reduction in costs. By achieving streamlined processes that are completed faster and more efficiently, less resources are required, resulting in decreased costs. In addition, less variation and defects lead to less cost of poor quality. Cost of poor quality includes costs that arise due to the gap between the desired and actual product or service quality. On the other hand, Lean Six Sigma increases revenue by enabling an organization to do more with less. Finally, a major benefit of Lean Six Sigma is an increase in employee engagement and effectiveness. Lean Six Sigma not only reduces costs and increases revenue, it positively affects people by engaging them and improving the way they work. By involving employees in Lean Six Sigma projects, they gain a greater appreciation for the impact of the work they do on bottom-line business results, as well as an appreciation for how the work of other employees and departments also contribute to success. And once employees get comfortable with Lean Six Sigma skills, learned through trainings or projects, they can proactively continue to improve their business processes, based on a well-established methodology. What is the DMAIC cycle? DMAIC, or DMAIC, is the data-driven process improvement cycle used to run Lean Six Sigma projects. The acronym, DMAIC, stands for the 5 interconnected steps or phases, that are, define, measure, analyze, improve, and control. Each phase has a specific purpose, with the overall goal of implementing effective and permanent process improvements. In the define phase, a project charter is created to clearly define the business problem, objective, project team, and high-level project timeline. The purpose of the measure phase is to determine the baseline performance of the process. In other words, we need to measure how the process performs today. In the analyze phase, the team analyzes data and the process flow to identify root causes of waste, variation, and defects. The improve phase is about generating and evaluating solutions to eliminate or reduce the identified root causes. The purpose of the control phase is to sustain the gains. This is achieved by creating or updating standard operating procedures, and ongoing monitoring of process performance, based on a control plan. In this view, you see that in all phases, different tools and templates are available that can be used to accomplish the individual phases. At the end of each phase, a checkpoint or gateway, highlighted and red in this graphic, needs to be passed in order to get to the next phase. Over the years, DMAIC has gained credibility as an improvement method that is easy to apply, suitable for teams, and effective at delivering performance improvement. Who are the key players within Lean Six Sigma? When deploying Lean Six Sigma, individuals across all business functions and levels in the organization need to play specific roles for a successful implementation of this methodology. The most important ones are sponsor, champion, black or green belt, process owner, and the project team. Let's see how the role of each one of the key Lean Six Sigma players is defined. The role of the executive sponsor is incredibly vital and important for the success of the Lean Six Sigma initiative. These people are typically members of senior management, or board members, and actively support the implementation of Lean Six Sigma in the organization. They provide the necessary budget and resources required for the program and individual projects. Champions are probably the single most important role within Lean Six Sigma. They take the vision and the direction from executives, and establish organizational goals that need to be addressed by using Lean Six Sigma. In addition, they also identify and prioritize project ideas, which then are assigned to the black and green belts. As department head or manager of an area, champions are responsible for the success of projects within their department or division. Once a project has been started, they provide motivation and consultation, and assist the black or green belt and the team in removing any issues and barriers that might stop the project from being successful. Black and green belts are professionals who act as project leader of Lean Six Sigma projects. They also serve as teachers and mentors of the team members. The most important role and responsibility of a black or green belt is to deliver a solution to a business issue to the process owner. While black belts are mostly 100% dedicated resources to Lean Six Sigma, and responsible for large-scale projects, green belts are traditionally only dedicated part-time within companies, and manage small to medium-scale projects. Another key player is the process owner. The process owner is a professional, who is responsible for the business process, that is the target of a Lean Six Sigma project. One of the most important and significant roles that the process owner has is to assist in the implementation of the solution that is delivered by the black or green belt, and to control the improved process after the project has been closed. He also assists with the identification of future project opportunities, because he is the one that usually knows the process intimately and feels the pain of any issues we have in our processes. Finally, the team members help the black or green belt to execute a project. They assist with things like data collection, experimentation, and other tasks associated with implementing the project. The main reason why these people are incredibly important, and need to be well selected, is because they provide the process expertise needed to analyze a process appropriately. Ideally, team members have received a training on the concepts and basic tools of Lean Six Sigma at a very introductory level, prior to their active involvement in a project. When to apply Lean Six Sigma? When facing a business problem, the following criteria should be met to successfully apply Lean Six Sigma. The problem is linked to a business process. A business process is a repetitive sequence of activities or tasks that produce a specific service or product for a particular customer. The process runs frequently, meaning that the process takes place on a regular basis, and not once a year. The more frequently the process runs, the more benefits can be generated over a certain period of time. There is no known solution for the problem. If you know the solution, you don't need Lean Six Sigma. Just do it. The root cause of the problem is not known. As Lean Six Sigma is a problem-solving methodology, focusing on identifying the root causes for a given problem, it only makes sense to apply the tools and concepts, if this job still needs to be done. There is data available. Data availability is critical to the speed and success of Lean Six Sigma projects. It's also the most essential condition to be met, when applying Lean Six Sigma. Without data, we cannot measure. And without being able to measure, we cannot quantify and evaluate the process performance, before and after improvements have been made. Course Review. In this course, you have learned that Lean Six Sigma is a data-driven approach, used to effectively improve business processes. About value stream mapping, and the 7 types of waste, Lean wants to eliminate. About the essence of Six Sigma, and the meaning of variation and defects. About the process improvement cycle DMAIC, and the purpose and contents of the 5 phases. About the different responsibilities and roles that are relevant within Lean Six Sigma. And finally, what criteria need to be met to apply Lean Six Sigma successfully. Thank you for listening, and attending this course.